Hey guys, this is a quick example on sound intensity and power. This is part of, whoops, sorry about that. This is part of unit number 7, dealing with waves and sound. This one says, an experiment requires sound intensity 0.968 watts per meter squared at the distance for 4.98 in any direction from a speaker. What total sound power is required? So before we go into the equation, let me show you more or less what's happening. So we have a speaker, and then this is the sound source. I'm going to pick green to show the waves. Oh, let's go for blue because I'm going to use blue for this problem. So there's a spherical wave, right? So we have a 2D version, so there's a circle. And then from there you have another spherical wave. Let's fix that one. And then you have another one, and so on. Again, let's fix that one. Okay. So those are your spherical waves. Try to picture it in a 3D version so you would have spheres, not circles. And something I want you to see is we were given a distance of 4.98 in any direction. That means a distance from the center of the speaker to, let's say, here. That's 4.98. I'm hoping that based on the outer circle, this is the radius. So we were given a radius. Let me show you why we need a radius. From your formula sheet, you'll see that sound intensity, I, is equal to power divided by the surface area of a sphere, so 4 pi r squared, where r is the radius, and we have the radius and we need it to solve for power. I want you to see that the radius is part of the denominator, meaning that when we increase the radius, that means we're going to get farther away from the sound source, so the intensity goes down because it's part of the denominator. As we get closer, right, to the speaker, we make this radius smaller, right? We get closer to the speaker, and the intensity goes up. That is your normal experience. The closer you are to a speaker, the louder you perceive the sound intensity, or the louder the sound intensity is. Okay, that being said, now let's actually solve the problem. Let's write down the given. So we were given sound intensity 0.968 watts per meter squared. And then we were given the radius, as we said, 4.98 meters. And we need to find power. Power equals question mark. Okay, based on that equation, this is going to be short and sweet. Intensity equals power divided by 4 pi radius squared. We have to solve for power, isolate power. Let me move this a bit more to the side. So to do that, we multiply times the denominator of the right side, 4 pi r squared, both sides. That will isolate the right side. I'm going to flip my equation, and then I have that power is equal to intensity times 4 pi radius squared. Now we just plug in our numbers. Power is equal to intensity 0.968 watts per meter squared. I apologize for my W. Now we have times the radius squared, 4.98 meters. Don't forget to square it. Quick unit check. So the meter squared here will cancel meter squared over here. We're going to be left with watts. That is what we want. That is the unit of power. So let's use decimals. Well, I had it halfway, but let me get started again. So 0.968 times the radius squared. Oh wait, don't forget the 4 pi. So 4 pi times the radius 4.98, and then we square that one. So there it is. We have a sound intensity of 301 point, let me round to nearest thousandth, so 0.678. So our power is going to be 301.678 watts. And that's it.